Let's come towards another state of matter, that is liquid. We will deal with the properties of liquids. Liquids have definite volume, means fixed volume, or but lack a definite shape. They do not have definite shape. Wherever you put the liquid, that will mean retain that shape. For example, you put the water in a glass, it will take the shape of the glass. Or whether you put the water in jug, that will take the shape of the jug. Example of liquid include water, blood, mercury, diesel, vegetable oil, milk, or etc. Liquids are made up of atoms or molecules. Some of the properties of liquids are, now I'm going to deal with the properties of liquid. Okay, come towards the first property of liquid, that is density. Liquids have closely packed molecules, means their molecules are closely packed. There is some space in liquid molecules, but solid molecules were tightly packed. Here the liquid molecules have some space. Okay. Okay, closely packed molecules resting in negligible empty space. Consequently, they are generally denser than gases. Okay, they are denser than gases. Okay, they have less density than gases, yet usually less dense than solid. Okay, yes, yet usually less dense than solid. Okay, if I talk about the compressibility, okay, liquids are generally considered incompressible. They cannot be compressed. Okay, they show slightly greater compressibility than solid. Okay, than solid, and are more difficult to compress than gases. The space between the molecules of liquid is greater than that of solid and less than of gas. Okay, means the space is greater than solid. The as solid molecules are tightly packed. Okay, and liquid molecules are closely packed, and lattice and gases molecules freely move. Okay, that is why liquids are generally considered incompressible, and they show slightly greater compressibility than solid, but they have compressibility than solid, greater compressibility than solids. Okay, if I talk about the fluidity, liquid molecules are in constant state of motion. Okay, they have fluidity, but they are in constant state of motion. Suppose the water is flowing in river, that is in constant state. That is why they slide over one another. Therefore, liquid have no fixed shape and adapt the shape of the container where they place. I already told you, if you put the water in jug, that will take the shape of jug. Whether you put the water and glass, that will take the shape of glass. If I talk about the kinetic energy, that is called moment energy, liquid molecules have higher kinetic energy than solid. They have higher moment energy than solid but lower than gases, as gases molecules are freely moving. Their kinetic energy decreases with drop in temperature and increases with the rise in temperature, which means that are inversely proportional. When the temperature increases, okay, increases, their can say kinetic energy increases. When the temperature when decreases, their temperature when temperature decreases, their kinetic energy decreases. Okay, sorry, it is directly proportional also. Okay, diffusion, if I talk about the diffusion, as I told you, diffusion is the moment of molecules from higher concentration to lower concentration. So liquid diffuse into other miscible liquids because their molecules move around. As their molecules move around, so they can be mixed to each other. Okay, they are mixable. Diffused and liquids occurs more slowly than gases. Okay, diffusion occurs more in gases than liquids. Okay. Okay, now come towards the properties of gases. As the gases have freely molecules, gases molecules are freely moving. So a physical state of matter that neither has definite volume or shape. It does not have fixed volume or fixed shape. Okay, gases do not have fixed shape or fixed volume. Is known as gas. Okay, example. Oxygen is there, carbon dioxide is there, methane is there. Methane is CH4 that is present in our cylinder. We use it for domestic, we can say. We use it. Methane is a domestic gas. We use it for cooking. It is a cooking gas. We use it for cooking. So we fill it in our cylinder. So it takes the shape of cylinder, as it does not have a fixed shape or fixed volume. All gases consist of a large number of tiny particles called atoms or molecules. If I talk about the properties of typical properties of solids include, okay, density. First one is density. Gases have a much lower density than solid and liquid. Okay, their density is much lower than, okay, solid and liquids. Okay, they have lower density than solid and liquid. Okay, if I talk about the compressibility, okay, gases molecules are widely separated from each other. They are widely separated from each other. Okay, they have a lot of space. Okay, they have much space within them. Okay, which facilitate their easily compression. Okay, gases molecules are compressible, okay, due to their space, okay, present between them. If I talk about the fluidity, gases molecules are in constant random motion, colliding with each other and with the walls of their container. For example, if you fill the gas cylinder with methane gas, okay, so there these gas molecules, okay, collide with each other with the walls of that container cylinder, okay, because they are in random motion. This properties allows gases to move and adapt the shape of the container. So they will take and adapt the shape of the container. The fluidity of gas enables them to show the properties such as diffusion, effusion, expansion, and compressibility. So diffusion is there, effusion is there, expansion is there. Okay, gases expand in that container. Okay, they compressed, they diffused. Okay, okay, they shift their places from one place to another, higher region to lower region. Okay, if I talk about the kinetic energy, gases molecules have higher kinetic energy than liquids and solid because due to their species. This is due to their mobility, negligible intermolecular forces. Okay, okay, and large spaces between them. There is large space between them. That is why they have, okay, more kinetic energy than liquid and gases, liquid and solid. Sorry, the average kinetic energy. The average kinetic the average kinetic energy of a gas molecule is directly proportional to the temperature of gas. Okay, means average kinetic energy of the gas is directly proportional to the temperature. As the temperature increases, so the moment of the gas molecule increases. As temperature increases, the average kinetic energy of the gases also increases. I told you the same. Okay, come to the diffusion of gases. Gases can diffuse faster than liquids and gases, okay, due to their high kinetic energy. I already told you, if gases have higher kinetic energy than liquids and solid, okay, so they can diffuse faster than liquid and gases. They have weak intramolecular forces, large spaces between molecules, the constant motion, frequent collision between them, in they continue to collide with each other. They have low density. Okay, lighter gases diffuse more rapidly than heavier. Lighter gases are there, they diffuse more rapidly than heavier one. For example, helium is there, that is molar mass 2 gram per mole, diffuse faster. Okay, helium is the lightest gas that diffuse faster than oxygen, that has molar mass 32 gram per mole, that is heavier than helium. So it diffuse later than helium. Okay.